All right, guys, this is Chapter 4, Lesson 3. This is day 1 of it, and it will take us 2 days to cover it. And it'll take maybe 5 minutes at the beginning to get the concept, and once we get the concept, it's going to go very, very nicely, this idea. But like I said, it'll take a few minutes to start just to get the concept. Today we want to figure out how do you graph a secant and a cosecant graph, when we've spent the last 4 or 5 days graphing sines and cosines. And sines and cosines are by far the most practical graphs, and those are the ones we spent most of the time on. But there were 6 trig functions, so it's kind of a fair question to ask, well, what does a secant graph look like, or a cosecant graph? And like I say, we'll establish the concept, and there's going to be a nice, quick, easy way to graph these. So let's start first with our secant graph. We want to get that graph, and the first thing you have to remember is, wait, what is the secant? And the secant is reciprocal of the cosine. So over here on the right, notice I didn't label this, but you knew what this was. This is the cosine graph over here. And knowing our cosine graph, we can look back at our secant graph and say, wait a minute, the secant is reciprocal, so if I know my cosine graph, I can figure out my secant graph. And maybe we start right down here with the y coordinates. We say, wait a minute, secant is the reciprocal. Let me take the reciprocal. And this isn't very interesting. The reciprocal of 1 is 1. The reciprocal of -1 is -1. The reciprocal of 1 is 1. Because a reciprocal, you go 1 divided by the number. So 1 divided by -1 is still -1. 1 divided by 1 is 1. The zeros, though, are a little more interesting. What is 1 divided by 0? Try that in your calculator. It makes no sense. That is undefined. So something funny happens for our secant graph when the cosine graph was 0. So that's undefined. Sorry, that's kind of illegible. But this will also be undefined. Okay, so we come up here to a cosine graph. We said here when the cosine was 1, the reciprocal is 1. Or at -1, it was -1. Or here where the cosine graph was 1, the reciprocal is 1. We said at these pi half values, it's undefined, meaning you can't put a dot there. So what we do, just to show that, is we put a vertical dotted line, meaning there's no value anywhere at pi halves or at 3 pi halves that makes sense for our secant graph. Okay, now let's look a little closer at this graph, and let's look at maybe right in here. If we came over here, our cosine graph, that value is a half. Do you guys know the reciprocal of a half? Reciprocal, you flip it over. Oh, that's 2. So that goes to here. Come a little lower. That value is a fourth. What's the reciprocal of a fourth? It's 4. So it shoots up to here. Or maybe try down here when it's -1/2. What's the reciprocal of -1/2? -2. What's the reciprocal of, let's see here, there, -1/4? -4. And so we start to get these dots, and that would be both here, and look over here when it's -1/2 or -1/4. We get the same reciprocal values. And we can plot and plot points, but it turns out we're going to get these little loops coming off the bottom, and these little loops coming off the top of our cosine graph to give our secant graph, because the reciprocal of any number less than 1 is going to be a number bigger than 1. And again, at 0, we cannot take the reciprocal, so wherever the cosine graph was 0, it makes no sense. So we put in these dotted lines, which we realize now are vertical asymptotes. So let's see what our calculator gives us for a graph when we take a look at this. So that's kind of the concept of it we got there. Now let's look at it. So let's graph here in our calculator. Check your mode. Make sure you're in radians. We are. And let's graph this. First, let's graph the cosine graph. So we got the cosine of x to see what that looks like. And then let's graph the secant graph. And how do I graph a secant in my calculator? How about 1 divided by the cosine? And then let's make this one darker just for emphasis. So I'll hit that. And a nice window on your graphing calculator is always zoom trig. So let's go zoom number 7. And here comes our cosine graph. That looks right. And then look at these loops coming off the top and the bottom of our cosine graph. That's our secant graph. So let me just save that here so we've got it. And just for the emphasis, what is our answer going to be? It's these loops here, that loop coming off the top and the bottom. That is our secant graph. It's not the cosine graph. Sometimes people graph the cosine graph and they leave that. You could make that, use that as a guide if you want, but that's not really our graph. If you want, you could put in the dotted lines, because everywhere the cosine graph is 0, you can't take the reciprocal of 0. So you can put in the vertical asymptotes in there, and that would give us our graph of secant. Okay, a few things remember with this, not quite as crucial as our cosine and sine graphs of key points, and I'll show you a shortcut in a minute. But things you should know, the secant of 0 was 1, pi was -1, and everywhere the cosine was 0, pi halves, 3 pi halves, 5 pi halves, you can't take the reciprocal, you get vertical asymptotes there. All right, that was secant. Let's look at cosecant. Graph of cosecant, would you agree cosecant? That's the reciprocal of sine. So cosecant of x is 1 over the sine of x. Are you thinking, let's graph sine, and let's take the reciprocal, and it's going to be exactly analogous to what we just did. So let's just put the sine on here first. Not going to put anything else. Let's get our sine graph. And now I know the cosecant is the reciprocal of that. So I take a closer look at my sine graph. When the sine is 1, the reciprocal of 1 is 1, or -1, or -1, or 1. Those don't change. When the sine is less than 1, any of these y values in here, the reciprocal is greater than 1. Oops, a little bit off there. And where the sine is 0, you can't take the reciprocal of 0. So you get it boxed in by these vertical asymptotes, and you're going to get these same little loops. And that's no big surprise, because sine and cosine are really the same graph, just with a shift. So secant and cosecant are really the same graph, just with a horizontal shift. Let's just double check that in our calculator. But I think we've got it pretty good. So that was sine. What's 1 divided by sine, otherwise known as cosecant? What does that look like? Let's make this dark. And sure enough, we get a graph not too far off from what I had graphed here. So there is our cosecant graph. And again, the key points at pi halves are at 3 pi halves. Then our reciprocal, because that's where the sine was 1 or -1. The reciprocal of 1 or -1 is 1 or -1. And wherever the sine was 0, you can't take the reciprocal of 0, so you have the vertical asymptotes there. Okay, is there a way we can sum this up? There is, and here is the quick, easy way to do this. Again, it's kind of nice to see why, and I think hopefully we've explained that, and now we've got the quick, easy way to do it. If I were on a graph, a secant or cosecant graph ever, I probably won't remember the key points. I probably won't remember the vertical asymptotes. Instead, I'm just going to graph the corresponding sine or cosine function. And once I've got that, I'll use the sine or cosine function to graph my secant or cosecant. I'll make little loops coming off the top of it. So if somebody asks you a question, could you graph y equals 3 cosecant of x? Your first answer is sure, but first let me graph y equals 3, let's see, reciprocal of cosecant is sine of x. So we're going to start with that graph. We'll come here, we'll put our key points on the graph, pi halves, pi, 3 pi halves, 2 pi, and it goes up to 3, it goes down to -3, and I know a sine graph starts at 0, goes up to 1, down to 0, down to -3, and back to 0. And this is not really my full graph, so I'm going to make this just dotted. I don't want somebody to be confused and think, oh, that's his answer. This is not my answer. Maybe I'll put another cycle on here just so you can kind of see what's going on here. And those are my guidelines. And now that I've got my sine graph, anywhere the sine graph was 0, I say, that's a vertical asymptote, because the cosecant is a reciprocal, and we can't take the reciprocal. Those are supposed to be straight vertical lines. And then, anywhere there's a loop, the top of the loop, my cosecant graph moves off the top, and the bottom of the loop it loops off the bottom, going downward. Some people think, oh, those are little parabolas. They look a lot like parabolas, but a parabola is never bounded between two asymptotes. So these aren't really parabolas. It's just called the cosecant graph. Oops, got another loop down here, don't we? And these loops are stuck in between these vertical asymptotes. They'll never get outside of those vertical asymptotes. So they just keep going up steeper and steeper and steeper, bounded between those two vertical asymptotes. So that is how you make a cosecant graph. Let's just try a couple more. And the difficulty level will not be as high, so it won't be as difficult as the sine and cosine graphs that we drew, which probably is a relief. So here's another question. Could you graph the secant of x minus pi thirds? And you conveniently avoid the question and say, well, I'll graph the cosine of x minus pi thirds. So I'm going to take my cosine graph and shift all my key points. So instead of 0, I'll shift to the right pi thirds. When I take my next key point, pi halves, and add on pi thirds, that comes out to 5 pi 6. Pi plus pi thirds is 4 pi thirds. I'm not going to take too much time on this because I've seen in class that you guys can do this. 3 pi halves plus the pi thirds is 11 pi 6. And 2 pi plus a third is 7 pi thirds. Sorry for the hesitation there. We've got that. And a secant, again, is reciprocal cosine. So let's make my scale, make this one, this negative 1. I know the cosine starts at 1 to 0 to negative 1 to 0 to 1. I won't get carried away. This is just a dotted graph. These are just my guidelines. Oops, that's supposed to be dotted. And maybe I'll continue a little bit more. I've got the pattern going here. And then anywhere my cosine graph was 0, I know those are vertical asymptotes. And then my secant graph are the loops, little loops coming off the top and the little loops coming off the bottom. Again, bounded in between those two vertical asymptotes. It'll never come outside of those vertical asymptotes. So the expectation on these graphs is the same. Can you label your key points on the x-axis? Can you give me your key points on the y-axis? If you can, then you've got a correct graph. All right, last one, same kind of business. Y equals cosecant. Avoid the question. Let's go with y equals sine of 3x. The key points get divided by 3. So instead of pi halves, we've got a pi 6, pi thirds, a pi halves. Oops, pi halves, I said it right. So pi halves, 2 pi thirds. I will graph sine. Again, let's make that 1, make that negative 1. Sine graph, I know, 0 to 1 to 0 to negative 1 to 0. Make that dotted. Maybe continue a little bit. And now don't forget, I've seen people stop right here. Don't forget to graph your secant, your cosecant graph. Vertical asymptotes. Anywhere my sine graph crosses the axis, because I cannot take the reciprocal of 0. I have these little loops coming off the top and off the bottom. And I know there's still 2 more graphs, the tangent and the cotangent. That will be the next part of the lesson. So those are your secant and cosecant graphs. To make a long story short, how do you graph those? And the answer is graph a sine or cosine. All right, that's done. Thanks for listening.